Ladies and gentlemen, this is Joe's Classic Video Games back with another cool arcade repair video for you today. I am just now getting my voice back. I've had laryngitis. I feel great, but I don't sound great. So you're just going to have to deal with it, folks. Come on, people. It's not that important. All right, so we had a gentleman bring us his Gravitar Arcade Game. We had one of these way back in the day. This is one of the early color vector games. Very unique. It's got that cool Atari look to it. And he brought us 3 or 4 games that he wants us to work on. This particular one, Joey doesn't mess with the vector stuff too much, but neither do I. We haven't had a bunch of these, but I think we can figure it out. This machine, I believe, has a new monitor board in it, so we get a look at that. But the gentleman's saying that when it comes up, it says something about no signal or something like that. So we're going to try to figure that out. So you're going to get to see a little bit of the modern and a little bit of the vintage. This is going to be one of your favorite videos ever if you can just deal with my voice sounding like this. So, the first thing I'm going to do is we got to get a look in the back of it because we don't know what's going on. If you don't know about the color vector arcade games, they stopped making those monitors about 1983, 1984, something like that. They're very valuable. So just the monitor in this machine is worth $600-700, maybe more. But I believe there's a company now that's making the boards that basically create the monitor, so you can use it with a different tube or to replace your original boards. So let's open up the back and see if that's what's in here, like I believe it is. All right, so we've got the back off. Basically, I want to make sure that nothing's in the wrong spot, burnt up, etc., etc. So let me show you the special part. Now, I have no experience with these. I haven't seen these at all. I've heard about them. Well, I'll show you this first and then we'll get up there. So basically the power comes in. You know, we always start at the wall. Power comes in, goes into this power brick on the bottom, which is the transformer and the fuses. There are fuses under this. That transformer is going to create different voltages by transforming the AC voltage into other AC voltages. Some of those are going to go over here to this rectifier board, which is going to turn some of those voltages into regulated and unregulated DC voltages. Okay, so this power supply also has new capacitors all over it. So somebody has rebuilt this, and it looks like they did a heck of a job on it. So I don't see anything standing out that's like, oh, this is junk. I wouldn't be surprised if they sent that out and had a pro rebuild it, because that looks really clean and really nice. Okay, so then those voltages are used to run the game board. Now the game board appears to have a little daughter board on it down here. That's probably a high score save kit or a multi-game kit, something like that. These are very complex boards, kind of hard to fix. So if there is a PCB problem, we're up woo-ha creek. You know what I'm saying, right? I can't say it on YouTube. I'll be censored. I don't want to get demonetized and canceled. You'll be up woo-ha creek without a paddle. There will be woo-ha all around the canoe. Okay, and so this board creates the, of course, the game play, so it's running software code to basically create the game, but it's also running video code to draw the video. Okay, and that's how most boards work. But on vector games, it's a little different. So that video, they call it the AVG. I think it's AVG. Is that right? No, they call it the vector state, I think. The vector state. So basically, it's generating all of the components of the vector display, right? The image that is going to be sent to the monitor. This is a replacement high voltage component for the monitor. Now, typically they had a flyback, which, how are they doing that? What in the world? Yeah, I'm going to have to look into this. There's no flyback. That can't work. Unless I just don't understand something. This is a CRT monitor. I mean, it's a vector monitor. There's a tube. You got to have a flyback or it ain't going to work. So I think that's our problem. That's what I would guess. But maybe I just don't understand what they're doing here. So, yeah, see how there's another connector there? So basically, there's a high voltage unit that creates the voltages that this deflection board needs. Now, this is a replacement deflection board as well. So the deflection board has been replaced, and the high voltage unit has been replaced, but you still need a flyback to connect to the tube. Unless I'm just completely ignorant on how tubes work, but I don't believe there's any way to pull that off without that. So we're going to have to go look up these Allen 1 boards and see what we're missing here. Sure looks like, usually the high voltage cage is not here. It's right here. And so it creates voltages that this board uses. But it also has a flyback that sends the extreme high voltage up to the anode of the tube. And, that's just how tube technology works. So I think we're missing parts, so we won't be able to fix that. Let me, we could probably order it or figure out where it's from or whatever. Let me look up the Allen 1 website and we'll check this out, and we should be able to get some pictures where I can illustrate to you what our problem is. Those of you that are all into arcade games, you see exactly what the problem is, but a lot of our viewers, they play arcade games and they're interested in this, but they haven't seen the inside of a vector arcade game before. So, if you're missing the flyback, the tube's not going to work. All right, that's more like it. He had the high voltage unit out of the machine. So yeah, this plugs into the CRT. Okay, that block that is on the side is not a replacement high voltage unit. It is it replaces all the transistors that are on the chassis, which is another issue that they had. Those things would slap the crap up, right? So so basically that's part of like the deflection part of it. So you need a high voltage unit, and then you need all the deflection stuff. So we need to put this back in if it looks all right. Here is our flyback. This has been fully recapped as well, it looks like. So, okay. So yeah, I don't know why this is out of it. There's also supposed to be like a cage that goes over here that sometimes if you don't have that cage, see the dirt? It's not really dirt, it's like, what would you even call that? It's not rust, really. It's, I don't know, whatever. You get the point. There's like a mesh that covers all this. That's like a shield. And that helps keep the lines from squiggling and stuff like that on the vector monitor. But you don't have to have it. Okay, so maybe we can pop this back in, but I kind of want to check all the voltages down in the bottom first, just to make sure all of the voltages are correct in the power supply, up to the board, and up to the monitor. So let's do that first. I need to get the schematics and see what voltages we're supposed to be getting out of that power block on the bottom. Make sure all of that's correct. All right, so the schematics for most arcade games, or a lot of arcade games, are on the internet. So here's what I'm going to do. I'm going to unplug this output from, this is the power brick in the bottom. This is the transformer. I'm going to unplug this output, and then we're going to plug it in where just this is plugged in, just this power brick in the bottom, the voltage going into it. And then we're going to check all these outputs. Now, it's not regulated, so that a lot of times they're off, but we just want to make sure that there's nothing crazy going on. So you can see the pin out of this 15-pin connector. So you have 10.6 volts. That is used to create the 5 volts that the game board runs on by the rectifier board that we talked about on the right side. You've got a couple grounds. You've got a 36-volt AC center tap. It says center tap. Yeah. So it's 36 volts AC, I believe, between the two of them. Here is the center tap going over here to one of the grounds, or both of the grounds. Then you've got 6.1 volts AC. I believe that's only used for the coin door bulbs. And then you've got a 50 volt AC center tap. I believe that's used for the vector monitor. The 36 volt is used by the game board for a bunch of other things. So, I believe. So, I'm going to check these voltages and see if any of them are off. Now, you got to keep in mind that some of them are DC voltages and some of them are AC voltages. The DC voltages are because there is a bridge rectifier mounted underneath that transformer, and there is a big, huge capacitor that Atari, or well, hobbyists have called the Big Blue, in the bottom of Atari power bricks on their vector monitors and their vector games and their raster games. That's a 27,000 microfarad at 15 volts DC capacitor. So the 10.6 is on the positive side of that, and then the grounds are on the negative side of that, which is, as you can see, the rectified DC voltage that comes off the transformer and through that bridge rectifier. So the voltage running into it, I guess they don't really tell you what that should be. Usually that 10.6 with nothing plugged in is going to be higher than that anyway. So we're just checking to see if these are here, if we get any weird, crazy voltage on one of them. Like instead of 50 volts, we've got 250 volts or anything. All of that shouldn't even be possible. But we're just checking to make sure this is all here. Now keep in mind the customer said too that the thing ain't working. He said that it's coming up and saying no signal. I don't know that it can say no signal, but maybe those new boards have a feature where it can actually say that. If that's true, you may have a problem with a voltage missing that would cause that. So we're going to start at the very beginning and just make sure all of our voltages are there. Okay, now when you're working on a vector game, notice how this is hanging. It's because that stuff's been removed. We'll put that back in. When you're working on a vector game, keep in mind there's some expensive crap in here. This Gravitar board's probably worth $400. And like I said, the monitor it's probably worth $600, maybe even more, right? The tube itself is worth money on a vector game. So in other words, you don't want to fry anything. You want to be careful with powering it up, right? So you can't be too cautious. So we're trying to isolate as we go through each level of the power to make sure that there's nothing that's crazy that's going to fry something. So one of the things I do is I just unplug the board. So that board isn't hooked up to anything. It can't get fried by power because there's nothing hooked to it, right? And then similarly, I unplug this, which is unplugging the entire monitor. These new boards, I would imagine, probably have some safety things built into them, diodes and things, so that they can't fry like that. But just in case, we're taking it easy, right? So I've got all of this unplugged. I've also unplugged this 15-pin connector that we were talking about. Now, if you look, all we have plugged in is the power cord from the wall going into the transformer, right? This wire right here, see how it's white, black, and green? That's going to be for like your marquee light or a fan somewhere or something. I think on this one it's the marquee light. These white and black wires here are for switches. So it's for the, sometimes there's a switch on the coin door. I think on this one it's just the on and off switch, right? And that's all that's hooked up. If you look, the other stuff is all self-contained. It's just ways for the fuses to be connected to the transformer and stuff like that. Here is the Big Blue we were talking about, and that's a newer one. You can just tell by looking at it. So that's been replaced. It looks to me like everything in this thing has been rebuilt. Okay. Even the game board, those blue potentiometers, I believe, may be replacement ones, possibly. Okay, so all we've got hooked up is this brick. Now, it might turn on the marquee light or something. So we can go ahead and safely hit the power. Nothing's wired up except that. I can't tell if the marquee light's on or not. I think it is. So it may be turned on the marquee light. So I have, using the wires here as a guide, I've got my ground in pin 5. I've got my red in pin 3. you know, which is the 10.6 volts DC that we were talking about. So it's telling us it's 15.57. But like I said, it's not regulated. So it's going to be high. It's going to get attached to other things and should lower it back down. So that's good. We were just checking to make sure it wasn't missing, or you don't have some kind of just crazy out of line voltage. So that's our first one and our only DC voltage that we need to check. So now we need to check a couple of the AC voltages. Okay, so I've still got the ground on pin 4. It was on pin 5 a minute ago, but those are connected together on the schematics. Pin 4 or 5 is ground. I just moved it because it gives us a little more room. And now we've got the red probe in pin 6. Okay, and that is one of the red wires on the schematics. You can see it right here, pin 6. So this is pin 6, this is pin 4. Okay, now that is the 36 volts AC center tap. And so the center tap is connected to ground. That's why on the schematics, that's why I've got it like that. So 36 volts AC center tap, one leg of it, we are getting 19 volts. So that's a problem, right? It's not 36. No, it's because it's center tap, so it should be half of 36. So it should be 18, it's 19. Very close. So we want to check the other tap, which is pin 7. It is also 19, so that's good. Now if we were to check between the two, if I can do that without getting electro killed. Whoa. I'll just pretend you didn't see that. There's our 36. It's actually 38, but that's fine. Okay, so both of those voltages are fine. So our 10.6 is there, it's pretty high, and our 36 is there, it's a little high. The reason that those are a little high is because our wall voltage is higher than it used to be. In the United States, it used to be about 115 volts. Now, here at our shop, it's about 126 volts. So, but it's not that important because it gets regulated later or it doesn't need to be. Okay, so let's check the next one. So next is the 6.1 volts, which is the coin door bulbs. But we don't have it plugged in, so the coin door bulbs aren't on. So it's pins 8 and 9. Okay, pin 9, I'm able to just put the probe in. But if you look at pin 8, it's turned around backwards in the socket. So it's the male pin instead of the female pin. The reason for that is because they call that the key. There's another one back here. They do it like that so that if you try to put this transformer, which is slightly wired slightly different, in another game, it won't plug in. And so they're doing that on purpose. So this should be 6.1, it says. And we're at 6.6. So that's good. No problems. And then finally we have the center tapped part of the transformer. That's the 50 volts AC that's created by pins, or that's connected to pins 10, 11, and 13. So I've got those hooked up, and it's 50 volts center tap, so it's 26 volts right now. I believe this one is the ground. So if we move over to pin 13, try not to have an electro boom situation. It is also 26 volts. And if we were able to do 10 and 13, there is our 50 volts. It's actually 53. Okay, so what did we learn? The 10.6 seems a little high, but that's typical for these. But all of the voltages are there. The power brick is working just fine. And we tested it at all of the outputs. So at least up into that connector, all the voltages are right except for the 10.6 being a little high. So what we're going to do now is turn it off, plug that back in, but we're going to leave this unplugged, and we're going to leave the monitor unplugged. So the next thing it's going to do is send those voltages over to here, and it will also maybe get our coin door bulbs to work. So we've plugged that in and turned it back on. Again, board and the monitor's unplugged. We do have our coin door bulbs, not that that's all that important, but it's nice. And then if you look over here on this rectifier board, there's a bunch of little lugs that you can test voltages at. So I've got the ground probe on the ground, and we're on DC. Let me put this where you can see it. Use my clever little meter that Todd gave us. Thank you again, Todd. The meter comes apart. One of them says 10.6 volts DC, or unregulated, right? So if you check, remember it was like 16 or something. Now it's 14.79, so it's come down a little bit just because this is plugged in. And then the other one that you want to worry about is the 5 volts going out. Now, they didn't really put a good lug to check the 5 volts on for whatever reason. But if you see this big wide trace right here, that is actually the 5 volts. So if you check there, we've got 5.2 volts. Now that's the voltage that everything's going to run off of. Now, so it's not 5, it's 5.2. The reason for that is because there's no load on it. So once you plug the board in, that will lower back down. Also, these have a sense circuit. I won't get all into that, but basically they have a way to tell if the voltage is too high and to lower it and raise it and all that. But if I check at the sense voltage, it's at the same, which tells me that this board has been modified so that the sense circuit is defeated. A lot of people hate that. A lot of people love that. I won't get all into it. I usually get rid of the sense circuit as well, but you can do it either way. So now what do we know? We know that that board is creating the 5 volts that everything's going to need to run, but we still have that other voltage, the 36 volts. So let's see what it does with that. If this is all very confusing to you, just pick up what you can. We're just testing to see if all the voltages are there that are listed in the manual. So here is the part of that regulator board that we're on. See the 10.3 volts, ours is like 14 or something, right? And the big fat trace that we're checking was this one right here, which you can see is connected to the 5 volt. Right? So ours is 5.2 volts, but it seems fine, right? The sense circuit we were testing here is also 5.2 volts. There's supposed to be a resistor between them, so this shouldn't really have any voltage on it if it's not hooked up. I don't know, it maybe a little bit trickles back through there, but anyway, what they've done is they've jumpered over this resistor. All right, so if you look at this other part, this is where the 36 volts comes in to the regulator board, rectifier board. And so these little, see how it says 36 volts AC here, and it also says 36 volts AC here? These are showing you that there are little lugs on the board that you can test at, like we were doing a minute ago. So the 36 volts is used to create these voltages. So a 12 volts, usually 12 volts is used for like audio amplification, stuff like that. Although on these, I think it's amplified on here. But anyway, plus 22 volts, negative 22 volts, 15 volts, and negative 15 volts, and then a negative 5 volt. So I don't know if this particular game uses all of those, but it is in the manual. So we'll see if we can find all of those little lugs and make sure all those voltages are there too. If one of these voltages is missing that the board needs, the board will never work right and you won't get a signal to the monitor. All right, so if you look over here, this is upside down. You'll just have to deal with it. See how it says -04? So this is the 04 revision of this audio regulator board. If you notice, there's a bunch of stuff that's unpopulated. And then someone has written Gravitar on there. So we got to check to make sure that this will work in Gravitar. Because in the manual we were just looking at, it's telling me 12 and -5 and all this. And if you look, that stuff is unpopulated. So it's hard to see because it's way up in there, but the 22 and the -22 are there, and they are correct. I checked. But the -5 and the 12 do not exist on this board. So we need to make sure that this board will run with just plus 22 and -22, and that it doesn't need the 12 and the -5. All right, so here is the wiring for the main PCB, and it's going to show you everything that it needs. This part up here is coming from the power supply, the board we were just looking at. So it needs plus 5 volt return, that's the ground, negative sense, positive sense, plus 5 volts regulated, 5 volts regulated, plus 22 volts, minus 22 volts, plus 5 volt return, that's ground, switch ground, LED start button, 10.3 volt unregulated, LED start, ground, plus 5, blah, 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 blah. Audio 2, audio 1, audio ground, all the buttons, the outputs, and that's it. So it does not need 12 or -5. So why do they show that on the schematic? It's because whenever they made this game, they probably didn't have a version of that power supply that didn't have that populated. So this was a design that they were using on all of their games, and it's capable of making plus 22, minus 22, plus 15, minus 15, plus 12, minus 5, and 5. But on this particular game, all it needs is the 5, the plus 22, and the minus 22. So they showed the schematic for that revision of the board that was available at the time. When they started putting it in production, they probably removed all that extra stuff off the power supply because they don't need it making 12 volts and -5 volts. So in other words, yes, it has the correct power supply in it. It could be, too, that the original power supply that was in it had that stuff populated, but it just wasn't used, because you can see that it's not even going to be wired up. So it could just be that someone swapped out that AR2 board, they call it, although it's an RA2 board. I never understood why they call it AR2, but whatever. Audio Regulator 2 board. It could be that whenever they got a new one, a rebuilt one for this cabinet, they got one without that stuff populated just because it's not necessary. So all that to say, we are now through the regulator board, and all of it appears to be working. So next step is to plug in the game board and see if the game will do anything that we can't see. All right, so we're still turned off, but I have plugged the board back in, and I have connected my meter up here to the 5 volt signal. Now remember, we were at 5.2 volts, but that's because the board wasn't plugged in. So usually once the board's plugged in, and this is specific to Ataris, it's not necessarily like that on everything, but once it's plugged in, it will drop that down a little bit. So we're confident that this power is fine and that power is fine, so there should be no reason that it fries the board. So we're going to try it. Yeah, okay. So 5.04, that's perfect. Ooh, what was that? So we've got 5 volts at the game board. I actually hear like vectors. We got sound. It's trying to do something. Let's see who's calling. All right, so you heard the sound, and we have our LEDs blinking. So normally on most of the games, they don't have an attract sound, or a lot of them don't. I don't know if Gravitar normally does. Remember, it's got that high score save looking thing on there, so it's probably got some added features. But usually you can tell by looking at these LEDs, if they're blinking, if it's on free play and they're blinking like this, then the game is at least trying to run. Now, if it's blinking much faster than this, there's somebody outside. Oh. It appears that the game is up and running. But here's the problem. If it's not sending anything to the monitor, it could still be running and not producing video. So we got to look into that next. So we're back to the schematics. Now, if you look, I am on the PCB part of the schematics. Now, look what they did. They're taking their negative 22 volts, running it through a voltage regulator, and creating a negative 15 volts on the main board. They're taking their 22 volts, running it through a voltage regulator, 7815, and creating a positive 15 volts on the board. Right? And then they've also got this third voltage that's 6.8 volts. So these are more voltages that we have to have, or it's not going to create the video. So further down into the schematics. These vectors are just awesome. They're very unique, and it's just really cool how they made them work. So the reason that they're changing the 22 volts into 15 volts, and you might just say, well, why didn't they just change the 36 into 15? Look, I don't know, but they did. They're using the 15 in the video output. Now remember, the 15 is turned into 15 on the game board. So it could be that there's a problem on the game board where it won't create the 15 that it needs. So as you can see, here is where the X output goes out, and then there's a similar circuit, that's the Y output. And you see right here, see the plus 15 and the negative 15. You need those voltages to create the, for it to send out the proper signal up to the monitor to create the image. So what I'm saying is we need to check, again, more voltages. We need to check and make sure that we've got our plus 15 and our minus 15. Let's see what the 6.8 does. There's our 6.8. Now, it's on a MC1495. It says that's a multiplier. If I remember correctly, they use that as like an amp where it makes the image bigger or something, or they need it to... I think they create the vectors like this, and then this like scales them or something like that, whatever. But again, it has something to do with the output. So if that voltage is missing, you won't get video output, and the monitor would not work. All right, so this area here is the output, the video output section, okay? And if you look carefully, there are more lugs with the voltages listed on them. If I can find them. So that says plus 5. That's another 5 that these chips here specifically use for the output. It's there. I checked. There is our negative 15. It's there. There's our plus 6.8. It's there, although it's 6.7. A little low. And then our positive 15. Where is it? Right there. Our positive 15 is a little low. It's 14.7. Not sure if that's a thing or not. So now we're to the situation where we know that the board seems right and that the voltages seem right. So the next thing we need to do is to try to test the output of the board with a monitor. And we got some pieces of a monitor, but that's all suspect. So we're going to try to hook up a scope to it. I don't use scopes much, but an oscilloscope is basically a vector monitor. You can use it to, or you can use it that way at least. So we've got an X output and a Y output. There's the Y out. The X out is here somewhere too. You can actually just run those, hook your probes to that and see if you can see it on a scope, and that will tell you whether or not the board is outputting video. All right, so I've got a probe hooked up to X, a probe hooked up to Y. I've got both of them grounded. Let's see what we got. We've got the display set on vectors, so if you hit display, I turned it off so that we could see it better. The light's on. Format YT. Format XY, check that out. Wham! There we go. So the video appears to be working just fine. So the board is putting out a signal. Now we're a little, some of it's cut off and stuff because I've got it hooked up backwards basically. I've got the X where the Y should be and the Y where the X should be. There's probably an easy way to switch that, but as you can see, the game appears to be running. I guess I could play with it like this. Yeah, that's a little more like it. Now, all these extra lines are because this is a LCD, digital scope. It's not a... How do we do this? I'm not much of a scope guy. If you had an old school scope with a CRT in it, it would look pretty much just like a vector monitor. you wouldn't see all those retrace lines. But the best I can tell, that's working just fine. So the monitor should be working just fine. So we could have shortcutted all of that checking the voltages by just hooking this scope up to it, right? But I like to be thorough, and I want to know for sure that the power supply is fine. And you know what? I know for sure that the power supply is fine. There's no problem with the power supply or the rectifier board, or it appears the video game board. Now there could always be some weird something going on. Our problem is in that monitor. And obviously without the flyback, high voltage cage in it, that's our first problem. So we gotta look into that first. All right, folks, so those vector monitors are fairly complex. We'll do that in a separate video. I hope this video will help you understand how the powertrain works and how to check it to see if you've got a problem with your machine. That's absolutely the first place to start when you have any kind of issues going on, and work through it the way we did, where you isolate things and check it in order from the wall all the way up to the monitor. So hopefully that'll help you with something. We'll see you on the next video whenever we'll dive into that vector monitor. I'm confident we'll be able to fix it. So we'll see you then. If you like the way that Atari did their power setup and everything, you're interested in more of that, check out this video of another Atari game that we worked through similarly, but that wasn't a vector game. We'll see you on the next video.